So today we're doing the Wingate cycling test. And so for this test, it's a 30-second test where the participant will cycle with 7.5% of their body weight in kilograms as resistance. So we had Hannah, and she's female, so her weight is 50.4 kilograms. So we went ahead and did some math beforehand. So 50.4 times 7.5%, her exercise weight is going to be 3.8 kilopounds, which is, in this, it's about equivalent to kilograms. So then for warm-up load, we're going to go 4 minutes before that. And at the end, the last 5 seconds of every minute in that warm-up, she's going to sprint. She's going to go as hard as she can for 5 seconds. And her load during the warm-up is going to be 0.8 kilograms, which is 20% of her exercise mass, which is 3.8 kilopounds. So we went ahead and did some exercise, or did some math beforehand, so we didn't show them the video. But so her force while she's exercising is going to be 37.3 newtons, which we found by multiplying her exercise weight times 9.81.
So the weight basket here weighs half a kilogram. So we're going to add 3 of these small weights to equal the 0.8 kilograms. And then for the warm-up for this, it's a 4-minute warm-up. She's going to pedal at about a comfortable pace, I think about 50 to 60 revolutions per minute. And in the last 5 seconds of each minute, she's going to go at an all-out sprint to see what that feels like. And then we'll go from there. So we're going to have her start pedaling at a comfortable pace, and then I'll let her know at the end of each minute, the last 5 seconds, to go at an all-out sprint. So a couple of the things that we can measure and calculate from what we're going to get from this test are absolute peak power and your relative peak power based on your body weight, as well as total work, relative work, mean power output, and your relative mean power output. During the 30 seconds of actual work on this test, we're going to be recording both revolutions per minute for increments of 5 seconds. That way we can estimate her peak power for each 5-second increment.
Yeah, and the way it works, you have somebody that, you can pull this up right here, and it'll remove the resistance, so she'll get pedaling like as fast as she can. And you'll count down from 3, and when you get to 0, and when you get 0, you drop it, and you start the timer. And then, so you'll have somebody counting how many revolutions she does, and then you add it all up.
Ready? 5, 4, pass that fast. Missing 2 minutes ago.
So after she's done with the warm-up, you can basically just hop off and walk around, or just step, or you can cycle with no resistance for a couple minutes. Most people like to.
While you get the weight set for the next part. So hers is 3.8 kilograms. So with this weight basket being half a kilogram, we need to load with 3.3. So I'm going to be recording the time. We're going to give her a few seconds to just pedal without the resistance at all. And we'll give her a 5-second countdown to get up to speed, and then I'll drop the weight. Will's going to start counting revolutions, and every 5 seconds I'll record the number that he says. Are you ready? Let's go fast. 5, 4, 3, 2, 1, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39,
Come on, 5
40,
seconds.
41, 42, 43,
Alright, you're good.
44.
Good job. So you can go ahead and settle it. Lighter resistance here. So now what we've done is calculated her total work, peak anaerobic power, and mean anaerobic power from the values that we got of her test. So total work can be found by multiplying the force that we've calculated earlier of 37.3 times the number of revolutions that she got total. So not for each 5-second increment, total number of revolutions, and then multiplying that by the length of the flywheel, which is standardized for the Monarch cyclometer, so it's 6 meters per revolution, and then dividing that by 1,000 to get kilojoules. So for that calculation, we got 9.62 kilojoules was her total work. We can also calculate peak anaerobic power, which is her maximum power during one 5-second time interval. So then we just multiply this, which is 37.3 times the peak number of revolutions, which is 12, times the length of the flywheel, which is 6 meters per revolution, and divide that by the 5-second interval to get 537.1 watts. Separately, we went ahead and calculated anaerobic power for each of the 5-second increments, and then from those values we were able to calculate the mean anaerobic power, which is the average of that peak anaerobic power equation for each of the 6 intervals. So as you can see, those are added up and divided by 6 to get 320.8 watts. So this is the average power that she was producing throughout the Wingate test. After that, we were able to calculate fatigue index, which is a percentage. So you take the highest power she produced in a 5-second interval, subtract the lowest power produced in a 5-second interval, and divide that number by the highest power again, and then multiply by 100 to get a percentage, and we got 66.7%.
Okay, so the first part for putting the mask together, you want to make sure these little rubber things go over this plastic piece. So if you can see, when the air comes through, it'll push this out a little bit and it'll have to get through. So you line it up with this arrow right here, if you can see it. So you want air to come in this side and come out this side. So this goes right here. You screw on this. And this one will go on the opposite side. In this part. And then it just screws on like that. And this valve's for all the spit that comes out. So you screw it on the bottom and screw this part on top. So the mouthpiece will go right here, and hold it like this, and tubes will go through the side.
So we're going to calibrate it. The first one is just for detection, and then you have 4 flushes. And then we have 5 that actually count that are for the calibration.
So you're gonna pump my oxygen.
Alright, so it's within 5%, so we're good.
last year.